Right now, if you were to look inside a tiny, tiny slice of your lower intestine, like a section no thicker than your fingernail,
Right.
there is this thriving metropolis of living, communicating organisms.
A massive metropolis.
Yeah, and the population of that microscopic city, it literally outnumbers every single human being who has ever been born, lived, and died in the entire history of our species, combined.
It's hard to even wrap your head around that number.
It really is.
Yeah.
And they aren't just, passing through. Right this very second, they are manufacturing complex chemicals, packaging them up, and sending them via this high-speed biological cable directly into the fear centers of your brain.
Which is just wild, right? Because it forces a complete rethinking of what it actually means to be human. I mean, we've operated for so long under this assumption that the brain is this isolated monarch, right? Just sitting up there in the skull.
Just barking orders downward.
Exactly. Completely separate from the messy plumbing of the digestive tract. But the reality of our biology is that we are not these solitary machines. We are walking, breathing ecosystems.
We really are. So welcome to today's deep dive. We are going to explore a completely invisible, yet totally dominant force over your daily life, which is the gut-brain axis.
And it's such a crucial topic.
It is. The mission today is to construct a real narrative arc here. We're going to look at the exact biological mechanisms of how, say, a stressful day at the office physically alters the ecosystem inside your stomach.
Yes.
And conversely, how the bacteria in your colon have the power to dictate your anxiety, your mood, and your overall behavior.
Because once you understand that your physical gut and your emotional mind are operating on this shared continuous loop, I mean, it changes everything.
Oh, totally.
The way you view mental health, digestion, even just the choices you make for lunch today, it fundamentally changes. We're looking at a system where psychology becomes biology and biology becomes psychology.
Okay, let's unpack this because we're pulling from a pretty massive stack of sources today. We've got psychiatric studies on emotional regulation from the Nurses' Health Study.
That's a big one.
Huge. We're looking at neurobiology research on germ-free mice, insights from the pioneering gastroenterologist Dr. Emran Mayer, some really fascinating philosophical essays on the divided mind, and medical research on the endocannabinoid system.
It's a lot of ground to cover.
It is. But I want to start by acknowledging that, on some level, humans have kind of known this for a very long time, right?
Oh, absolutely.
I mean, it was baked into our language and our ancient practices way before we had the microscopes that actually prove it.
Yeah, think about how we talk.
Right. We talk about having a gut feeling when a situation feels dangerous, or we complain about being hangry when an empty stomach makes us incredibly irritable.
Or getting butterflies when you're anxious.
Exactly. And if you look at ancient traditions, like Ayurvedic medicine from the Indian subcontinent, they have been prescribing highly specific dietary regimens, fermented foods, and gut cleanses for thousands of years.
Because they intuited that if the digestive tract was unbalanced, the mind would just follow right along.
Right. They observed that cause and effect over millennia. But then Western medicine, particularly in the 19th and 20th centuries, took this highly compartmentalized approach.
Oh, very much so.
The body was divided into specialties. Gastroenterologists looked at the stomach and intestines as a purely mechanical system, like just a passive, relatively unintelligent plumbing tube.
Just pipes. Food goes in, enzymes break it down, nutrients get extracted, and waste is expelled.
Yeah, and if there was a problem, it was a mechanical blockage, an ulcer, or an infection. Meanwhile, psychiatrists looked exclusively at the brain and neurochemistry, and never the twain shall meet.
But the anatomy, the actual physical wiring of the body, tells a completely different story.
Right.
When anatomists really began mapping the nervous system within the digestive tract, they discovered a network so incredibly dense and complex that it earned its own distinct classification.
The enteric nervous system.
Exactly. We call it the little brain. Your gut contains hundreds of millions of neurons.
Wait, really? Hundreds of millions?
Yes. That is more neurons than you have in your spinal cord.
Oh, wow.
It operates with a vast array of neurotransmitters, and it can actually function independently. Like if you were to sever the connection between the brain and the gut would just continue to perfectly coordinate all the complex muscular contractions of digestion entirely on its own.
That is wild. So you have this independent, highly intelligent little brain lining your digestive tract. And residing right inside that territory is the microbiome.
Yeah.
This massive, sprawling population of bacteria, viruses, fungi, and archaea. And when we look at the evolutionary history here, I mean, it requires a bit of humility on our part, right?
After.
Because we like to think we are the pinnacle of life on Earth. But from the perspective of evolutionary biology, human beings are essentially a highly elaborate Uber ride for these microbes.
That is the absolute perfect way to look at it. Microbes are the OGs of life on this planet.
The original gangsters.
Exactly. They have been here for roughly 3.5 billion years. I mean, they engineered the atmosphere, they established the carbon cycle. Humans, by comparison, are just a biological blip.
Right, we just showed up.
We evolved into a world that was already entirely saturated with them. So instead of fighting them, our bodies evolved to incorporate them.
Makes sense.
We outsourced massive amounts of our genetic and metabolic needs to these ancient organisms. They have millions of genes dictating chemical processes, whereas the human genome only has about 20,000.
But if they're just hitching an Uber ride and digesting our food, why do they need to talk to our brain? Because earlier we mentioned this high-speed biological cable connecting the two. Let's talk about the physical infrastructure.
Okay.
Because the traffic patterns on this superhighway makes zero sense if you assume the brain is the absolute boss.
Right, so the physical connection you are referring to is the vagus nerve. It is the longest and most complex of the cranial nerves. It emerges directly from the brainstem, travels down through the neck, touches the heart and lungs, and then branches out like the roots of a tree, just wrapping itself around your entire digestive tract.
Wow.
It is the primary communication line between the central nervous system up top and the enteric nervous system down below.
Right. And if I look at this through the old lens of human anatomy, I would assume this massive fiber optic cable is just the big brain constantly barking orders down to the stomach, like, digest this, stop moving that, secrete more acid.
That's what most people think.
But when researchers actually measured the electrical impulses traveling along the vagus nerve, they found the exact opposite.
They did. They found that roughly 80 to 90% of the nerve fibers in the vagus nerve are afferent, meaning they are carrying sensory information from the gut upward to the brain.
Wait, stop there. So the gut is constantly uploading massive high-resolution data files to the brain, while the brain is only sending, like, tiny intermittent text messages back down.
Pretty much, yeah.
But if the brain is supposed to be the master command center, why doesn't it just hit mute on the gut? I mean, why is the brain allowing a colony of bacteria in the large intestine to flood its servers with constant sensory data?
It's a great question.
What could possibly be so important down there that the brain needs a minute-by-minute update?
To answer that, you have to look at what the gut actually represents biologically. Your digestive tract is a hollow tube running through the center of your body. So biologically speaking, the inside of your gut is actually the outside world.
Oh, that's weird to think about, but yeah.
It's a massive surface area where foreign material, food, toxins, pathogens, environmental chemicals all comes into direct contact with a single cell-thick barrier inside you.
So it's a border crossing.
It is the most active, high-stakes border crossing in your entire body. And because of that, 70% of your entire immune system is stationed right there.
70%.
Yeah, 70%. Just lying in wait in the gut tissue, microns away from those trillions of microbes. Now think about the brain. It's locked inside the dark, sterile vault of your skull. It is completely blind.
Right.
It relies entirely on the vagus nerve to report what is happening at the border. The vagus nerve is studded with receptors that are literally tasting the chemical environment of the gut.
Tasting it.
Essentially, yes. It's sensing immune cytokines, hormones, and the chemical byproducts of the bacteria. The brain needs to know, is the environment safe? Is there an infection? Are we starving? The brain literally cannot regulate your survival without that constant stream of intelligence from the gut.
Okay, so the gut is the reconnaissance team, and the brain relies on its reports to know if the world is safe. But because they are locked in this constant, intimate dialogue, it creates a massive vulnerability.
It really does.
We have to look at what happens when the communication breaks down, or worse, when the brain starts generating a catastrophic interference signal. Because modern life isn't just full of physical threats, it's overflowing with psychological ones.
And to your biological hardware, there is no difference between the two.
Really? None?
None. We often treat emotional stress as a purely psychological phenomenon. We think a looming deadline, a toxic boss, or a suppressed emotion is just, all in our head.
Right.
But to your gut and to the microbes living there, chronic emotional distress is interpreted as a literal physical emergency.
I want to paint a picture for you, the listener, of how this psychological trap actually feels. If you are listening to this right now while sitting in traffic, commuting to a corporate job you absolutely dread, where you have to put on a fake smile for 8 hours, you are living this reality.
Yep.
Notice how your stomach feels right now. That tightness, that low-level knot, that is not just a metaphor. That is your vagus nerve receiving a panic signal from your brain.
And to understand the origin of that panic signal, we have to look at the philosophy and neuroscience of the divided mind.
Oh, this is fascinating.
There is a deeply compelling framework built on the work of psychiatrist Ian McGilchrist. He views the brain's two hemispheres not just as different processing centers, but as competing operating systems with entirely different values.
Let's define those operating systems. You have the left hemisphere,
Yeah.
which McGilchrist characterizes as the manager, right?
Yes.
The left hemisphere craves certainty. It loves categories, rules, metrics, and societal expectations. It's the part of you that looks at a spreadsheet and feels a sense of calm. It's the voice that says, take the safe path, conform to the corporate culture, do what realistic people do.
Exactly. And then you have the right hemisphere, which is the explorer.
Right.
The right hemisphere processes the world holistically. It understands nuance, metaphor, genuine connection, authenticity, true desire. It doesn't care about the spreadsheet at all. It cares about meaning.
And the argument is that in our modern, hyper-structured, metric-driven culture, the left hemisphere has essentially staged a biological coup.
A total takeover.
From the time you are a child, you are taught to perform for the manager. You draw a purple elephant and the teacher tells you to use gray because elephants are gray. You want to study music, but your parents tell you to study finance because it's practical.
Yeah.
You're miserable in your high-paying job, but society tells you how lucky you are to have that title. So layer by layer, year by year, the manager learns to override the explorer. You spend decades building an identity that is entirely a performance.
And this creates a devastating psychological and biological trap. Philosophers often liken it to the Ouroboros.
The ancient symbol of the serpent eating its own tail.
Exactly. It represents a cycle of endless self-consumption.
Because the performance works. You get the promotion, you get the societal approval, and the left hemisphere uses that external validation to justify burying your authentic self even deeper.
But here's the thing, the authentic self, that right hemisphere's drive for meaning, it doesn't just evaporate, it gets locked in the basement. And it takes an enormous, constant supply of neurological energy to keep it suppressed. This internal war creates a state of chronic, subconscious, unresolved stress. You are living in a constant state of threat, but the threat isn't a predator in the bushes. The threat is your own suppressed identity trying to burst out. The mind is literally destroying itself to sustain a false version of itself.
Okay, so how does a philosophical concept like the Ouroboros, this internal psychological war between authenticity and conformity, actually destroy the physical tissue of my digestive tract? Like, why does the body care if I'm unfulfilled at my job?
Because the brain translates that chronic internal psychological conflict into the exact same chemical language it uses for a physical predator.
Seriously?
Yes. When you live in a state of chronic emotional suppression, your amygdala, the brain's fear center, is constantly activated. It triggers the HPA axis, which is the hypothalamic pituitary adrenal axis.
Right.
Your body is flooded with cortisol and adrenaline. It elevates levels of glutamate, which is a major excitatory neurotransmitter. Basically, your sympathetic nervous system, your fight or flight response, is locked in the on position.
And when you are running from a predator, your body radically reprioritizes its resources. It doesn't care about long-term maintenance. It only cares about surviving the next 10 minutes.
Exactly. Blood is shunted away from your digestive organs and pushed into your skeletal muscles so you can run or fight. In the gut, this sympathetic override causes an immediate halt to gut motility.
It just stops.
It just stops. The smooth muscle contractions that move food through your system, called peristalsis, freeze. Because if you are about to be eaten by a tiger, you don't need to be wasting precious energy digesting a sandwich.
So that explains the knot in the stomach, the bloating, the indigestion. The physical machinery has literally been powered down by the brain's panic signal.
Yes.
But it goes so much deeper than just paused digestion. The actual structural integrity of the gut starts to fail.
It really does. So the lining of your intestinal tract is a single layer of epithelial cells, just one layer thick. And between these cells are complex protein structures called tight junctions. They act as the gatekeepers, determining what microscopic nutrients are allowed to pass from the gut into the bloodstream, and what toxins and bacteria must be kept out.
I think a good analogy here is to imagine your gut lining like a line of massive bouncers outside an exclusive nightclub.
Ooh, I like that.
Yeah, they are standing shoulder to shoulder, holding hands, forming an impenetrable wall. They let the VIPs, the digested vitamins and nutrients, slip through, but they block the chaotic crowd on the street.
Yeah, that's a great visual. Now imagine what happens when those bouncers are subjected to constant, unrelenting stress. Chronic exposure to stress hormones, particularly cortisol, and the resulting localized inflammation actively degrades the proteins that make up those tight junctions.
The chemical bonds weaken.
Exactly.
So the bouncers get exhausted, their grip slips, they let go of each other's hands, and gaps open up in the wall.
Precisely. And suddenly the chaotic crowd from the street, undigested food particles, bacterial endotoxins, pathogens, they spill straight through those gaps and into the VIP section, which is your bloodstream. This is a condition known medically as intestinal epithelial permeability. In functional medicine, it is simply called leaky gut.
And remember, 70% of your immune system is stationed right on the other side of that wall. So when the barrier breaks, the immune system sees all this foreign material flooding into the blood, and it completely freaks out. It assumes you are under massive infectious attack.
The immune system launches a massive systemic inflammatory response. It releases waves of inflammatory cytokines that travel throughout your entire circulatory system.
So it's everywhere.
Everywhere. This creates systemic, chronic inflammation. Your joints, your heart, and crucially, your brain. Those inflammatory markers cross the blood-brain barrier and cause neuroinflammation, which profoundly exacerbates feelings of anxiety and depression.
It really is the Ouroboros. The psychological suppression creates a stress response, which breaks the physical gut barrier, which triggers massive immune inflammation, which travels up to the brain, inflames the neurological tissue, and makes the psychological stress even worse.
It's a vicious cycle.
The serpent is meeting its own tail,
Yeah.
and it's using your immune system as the teeth.
Wow, yeah. But the breakdown of that epithelial barrier isn't just a structural failure. We have to consider what this hostile, inflamed, stress hormone-soaked environment does to the trillions of living organisms trapped inside the gut.
The microbes.
Right. For the microbiome, their house is essentially on fire. And like any living ecosystem, when the environment radically changes, the microscopic populations within it adapt, shift, and mutate.
Which brings us to the actual chemical reaction of the microbes. Like, how do they respond to your emotional distress? And we actually have incredibly robust hard data on this. I want to dive deep into a study published in Psychological Medicine, drawing on data from the Nurses' Health Study 2.
This is a landmark study.
It's a massive, long-term epidemiological study. But for this specific trial, researchers looked at over 200 female nurses, analyzing both their emotional regulation strategies and their gut bacteria.
And what makes this study so powerful is the methodology. They didn't just ask the nurses how they felt on a survey. They required these women to provide regular stool samples over the course of 6 months.
Dedication.
Truly. And they didn't use basic genetic testing. They used shotgun metagenomics sequencing.
Let's explain what that actually means, because it highlights how granular this data really is. Older microbiome testing, like 16S sequencing, just looked for one specific marker gene to identify what species of bacteria were present.
Right.
It's like looking at the cover of a book just to see the title. But shotgun metagenomics takes all the genetic material in the sample, shatters it into millions of tiny pieces, sequences all of them, and uses supercomputers to piece the entire genetic code back together.
It allows researchers to see not just who is there, but exactly what they are doing. They could map all the metabolic pathways and chemical factories those bacteria possess. They saw the exact functional capacity of the microbiome.
And the psychological metric they used was fascinating. They didn't just categorize these women as happy or sad. They looked specifically at the mechanics of how they handled stress. They compared two very different emotional strategies.
Cognitive reappraisal versus emotional suppression.
Let's define those.
Sure. Cognitive reappraisal is the ability to take a stressful or negative situation and reframe it. It's acknowledging the stress, but finding a way to view it as a learning opportunity, or placing it in a broader, less threatening context. Your left hemisphere might panic, but you consciously intervene to calm the system down.
Got it. And the other?
Emotional suppression, on the other hand, is the Ouroboros. It is the conscious or subconscious burying of negative emotions. It's feeling enraged or terrified, but pasting on a smile and pretending everything is completely fine.
And when they cross-referenced those psychological profiles with the shotgun metagenomics data, the results were incredibly stark. The women who habitually engaged in emotional suppression, the ones burying their authentic feelings, had a visibly less diverse microbial community in their gut.
Which is a critical finding. Because in the world of microbiome science, diversity is the ultimate metric of health. A highly diverse ecosystem is resilient. It can handle dietary changes and fend off pathogens. Chronic emotional suppression was literally starving out entire species of beneficial bacteria, reducing the resilience of the whole system.
But it gets much more specific than just overall diversity, right? They found that harboring and suppressing negative emotions provided a distinct survival advantage to very specific strains of bacteria.
Yes, they did.
Women with high levels of emotional suppression showed a significantly higher abundance of Firmicutes bacterium CAG94 and Ruminocaceae bacterium D16.
Quite a mouthful, but yes. And on the flip side, those exact same bacterial species were far less prevalent in the individuals who practiced cognitive reappraisal and reported higher positive emotions.
Why do those specific bacteria thrive when you are miserable?
It comes down to the chemical environment we discussed earlier. When you are stressed, your gut motility slows down, your digestion changes, and your intestinal walls leak. The pH of your gut shifts. The availability of oxygen in the tissue changes.
It becomes a swamp.
Exactly. Certain bacteria, like these specific Firmicutes strains, are highly adapted to survive in that inflamed, stagnant environment. When the beneficial, stress-sensitive bacteria die off, these opportunistic strains see a void and rapidly multiply to take over the real estate.
It's a terrifying thought. Feeling trapped in your life actually breeds a specific demographic of bacteria in your colon.
It's unsettling.
But remember, shotgun sequencing tells us what the bacteria are doing, not just who they are. And this is where the study gets truly profound. The researchers found a negative emotional suppression resulted in a massive downregulation of specific metabolic pathways. The bacteria literally stopped producing certain chemicals.
Specifically, they saw a lower abundance of the pathways responsible for synthesizing pantothenate and coenzyme A, or CoA.
I need you to break down coenzyme A for us. Why is it a big deal if my gut bacteria stop making it?
Coenzyme A is an absolutely foundational molecule for human biology. It is central to the Krebs cycle, which is how your mitochondria generate cellular energy.
Okay, so it's energy.
Yes. And it is required for the synthesis of fatty acids, cholesterol, and the neurotransmitter acetylcholine. Without sufficient coenzyme A, your cells literally cannot produce the energy they need to function.
So, when you are chronically suppressing your emotions, the physical environment of your gut becomes hostile. The bacteria that manufacture coenzyme A die off. Your body is starved of a critical energy precursor.
And what happens?
You feel physically exhausted, lethargic, and brain fogged. We treat depression as a state of mind, but your microbiome is literally shutting down the energy factories at a cellular level. It proves that psychological distress is a biochemical event.
And if we want to truly understand the sheer power these microbial chemicals exert over the brain, we have to look at the absolute extreme, like what happens if you remove the microbes entirely? This leads us to a fascinating cutting-edge study published in 2025 by you and colleagues on germ-free mice.
I love this study. So scientists took a specific breed of laboratory mice, the C57BL6J strain, and they bred them inside sterile, pressurized isolator bubbles.
Completely isolated?
The food is sterilized, the water is sterilized, the air is filtered. These mice are born and raised without encountering a single bacterium, virus, or fungus. They have absolutely zero microbiome. They are completely artificially pristine.
Which is completely unnatural for any mammal.
Right.
And the behavioral results are striking. You might think a mouse free of all pathogens would be incredibly healthy, but instead, these germ-free mice exhibit severe, crippling anxiety behaviors. They are terrified of open spaces, they constantly display hypervigilance, and they are essentially locked in a perpetual state of fear.
Here's where it gets really interesting. To understand why these sterile mice were so terrified, the researchers didn't just watch them run through mazes, they cracked open their neurobiology.
He zoomed right in.
They looked at the basolateral amygdala, or the BLA, which is the primary fear processing center of the mammalian brain.
And when they looked at the brain tissue at a cellular level, they found something remarkable. The neurons in the amygdala of these germ-free mice showed a massive upregulation of the CFOS gene.
Explain the CFOS gene. What does that do?
The CFOS gene is what neuroscientists call an immediate early gene. It is a biological marker of neuronal activity. When a neuron fires rapidly, CFOS expression spikes.
Okay.
So the fact that CFOS was massively elevated meant that the fear neurons in these mice were wildly hyperexcitable. They had unusually high rates of spontaneous synaptic activity. They were firing constantly, even when there was no actual threat in the environment.
I picture the amygdala in these germ-free mice like a car alarm with a broken off switch.
That's a good way to put it.
A heavy truck drives by, the alarm goes off, but because the wiring is faulty, it just keeps blaring for hours. The brain is sensing danger everywhere because there is no biological signal telling it to calm down. So what is the missing off switch?
The researchers pinpointed the exact molecular failure. The hyperexcitability was caused by a severe deficit in something called small conductance calcium-activated potassium channels, or SK channels.
Let's get into the mechanics of that.
Yeah.
How does a potassium channel act as a brake for the brain?
Well, neurons communicate through electricity, right? Specifically through the flow of charged ions like sodium, calcium, and potassium across their cellular membranes. When a neuron in the amygdala gets stimulated by a threat, calcium floods into the cell and the neuron fires its electrical signal.
Right.
But it can't just stay active forever, it needs to reset. That's where the SK channels come in. When calcium enters, it triggers these SK channels to open up and let potassium flow out of the cell.
So the potassium leaves.
Yes. This loss of positive potassium ions hyperpolarizes the neuron, meaning it forcefully drops the electrical charge back down to a resting state. It's an automated pressure release valve that calms the neuron down.
But in the germ-free mice, these SK channel currents were incredibly weak. The pressure release valves were stuck closed. The neuron fires, but the potassium can't escape, so the neuron just stays highly charged and keeps firing. Panic, panic, panic.
Exactly. But here is the critical intervention of the study. The researchers wanted to see if they could reverse this purely through the gut. They took these highly anxious, germ-free mice, and they colonized their digestive tracts with live, healthy microbes.
Yes.
The anxiety behaviors plummeted, the SK channels in the amygdala physically restored their function, and the hyperexcitability of the neurons was suppressed.
Wait, how? How does a living bacterium in the colon fix a microscopic potassium valve in the center of the brain?
That is the magic of microbial metabolites.
Okay.
The researchers isolated exactly what the bacteria were doing. They found that it wasn't the physical presence of the bacteria itself that reached the brain, but the chemicals they were manufacturing, specifically a class of compounds called indoles.
Indoles. This is crucial because indoles are not some synthetic lab chemical. They are naturally occurring compounds produced when your gut bacteria break down tryptophan, an amino acid, and when they ferment cruciferous vegetables. We were talking about broccoli, cabbage, Brussels sprouts, kale.
Yes. When you eat broccoli, it travels down to your large intestine. The specific bacteria equipped to digest it break down those tough fibers and release indoles as a byproduct.
And then what?
These indoles are small enough to pass through the gut barrier, enter the bloodstream, circulate up to the brain, cross the highly selective blood-brain barrier, and bind directly to the cells in the amygdala to facilitate the opening of those SK channels.
Just pause and think about the physical reality of what you just described. A chemical molecule is forged inside a microscopic bacterial factory in your colon, fueled by a piece of broccoli you ate for lunch.
It's amazing.
That molecule enters your blood, travels up your neck, enters the deep emotional core of your brain, and acts as the physical key to unlock a potassium valve that forces your fear neurons to calm down.
It is breathtaking biological choreography, and it proves that our brains did not evolve to manage fear all by themselves. Evolution built our neurological defense systems with the absolute expectation that microbial chemicals would be present to regulate them. Without the microbes, the hardware literally breaks.
And if these bacterial metabolites act as the physical off switch for our fear centers, it completely reframes our understanding of where our neurochemistry actually comes from. We have to open the door to the neurotransmitter factory. Because it's not just indoles. The microbes are manufacturing the heavyweight chemicals of psychiatry.
Oh, absolutely. If you ask the average person where serotonin is produced, they will point to their head.
Right.
Serotonin is the neurotransmitter we most heavily associate with mood stabilization, feelings of well-being, and sleep regulation. Selective serotonin reuptake inhibitors, or SSRIs, are the most commonly prescribed antidepressants in the world, specifically targeting the brain. But the reality is that up to 90% of the body's entire serotonin supply is produced in the gastrointestinal tract.
90%. How are the bacteria making it?
It's a collaborative effort. Your gut lining contains specialized sensory cells called enterochromaffin cells. These cells hold the massive stores of serotonin. Specific species of gut bacteria, such as Enterococcus, Streptococcus, and certain spore-forming bacteria, produce chemical signals, often short-chain fatty acids like butyrate.
And those signals do what?
They physically interact with these enterochromaffin cells and stimulate them to synthesize and release serotonin.
So the bacteria are essentially pressing the pedals that run the serotonin factory. And it's not just serotonin either.
No, specific strains like Lactobacillus and Bifidobacterium actively synthesize GABA, or gamma-aminobutyric acid.
It's a calming signal.
Exactly. GABA is the brain's primary inhibitory neurotransmitter. If glutamate is the gas pedal for the nervous system, GABA is the heavy brake. It induces relaxation, reduces muscle tension, and promotes sleep. Even dopamine, the molecule of motivation, reward, and motor control, is heavily modulated by the presence of specific microbial populations.
But with all these powerful chemicals sloshing around, serotonin, GABA, dopamine, indoles, cortisol, adrenaline, and the immune system constantly teetering on the edge of inflammation, there has to be a master conductor.
There is.
There has to be a regulatory network trying to keep all this chaos in check. And this brings us to an incredibly vital biological system that most people have never even heard of, which is the endocannabinoid system, or the ECS.
It's astounding that the ECS isn't taught in basic high school biology, considering it is present in all mammals and regulates nearly every critical physiological function we have.
It's a huge deal.
It was only fully identified in the early 1990s. The endocannabinoid system is a vast, complex cell signaling network designed to do exactly what you just said, act as the master conductor. Its singular biological goal is homeostasis, the maintenance of a stable internal environment despite external fluctuations.
Let's break down the anatomy of the ECS. What is it actually made of?
It has three core components. First, you have the endocannabinoids. These are the lipid-based neurotransmitters synthesized by your own body. The two most studied are anandamide, often called the bliss molecule, and 2-AG.
Okay, that's one.
Second, you have the receptors that these molecules bind to. The primary ones are CB1 receptors, which are incredibly dense in the brain and central nervous system, and CB2 receptors, which are predominantly located on immune cells and throughout the peripheral nervous system.
And the third?
Finally, you have the metabolic enzymes that build these endocannabinoids when they are needed and break them down immediately once their job is done.
And what makes the ECS so unique is how it communicates. Traditional neurotransmitters travel in one direction, right? They are released by the presynaptic neuron, cross the gap, and hit the postsynaptic neuron to send the message. But endocannabinoids travel backward.
Yes, it's called retrograde signaling. When a postsynaptic neuron is being overstimulated, say, it's being bombarded by pain signals or excessive glutamate from a stress response, it synthesizes endocannabinoids on demand and fires them backward across the synapse.
To get the sender.
Exactly. To bind to the CB1 receptors on the firing neuron, it essentially acts as a localized dimmer switch, telling the overactive neuron, message received, you can quiet down now.
And in the gut-brain axis, the ECS is absolutely everywhere. It is the system desperately trying to stop the Ouroboros. It is heavily concentrated in the enteric nervous system. It controls motility, trying to keep the digestive contractions smooth and steady.
It's working overtime.
Yeah, it modulates the immune cells via the CB2 receptors, trying to extinguish the systemic inflammation caused by leaky gut. And it actively works to maintain the tight junctions, keeping those bouncers holding hands.
And because the ECS is so deeply integrated into the gut's defenses, it has become a massive frontier for medical research, specifically looking at external interventions when the internal system gets overwhelmed.
When you run out of natural tone.
Right. When chronic stress depletes your natural endocannabinoid tone, can we supplement it from the outside?
Which leads us directly into the clinical data surrounding medical cannabis. Now, I want to be extremely clear here for you, the listener. We are not weighing in on the politics, the legalization debates, or the recreational culture of cannabis.
No, not all.
We are strictly examining the biological mechanisms and the clinical data published in peer-reviewed journals. Because from a purely biochemical standpoint, the cannabis plant is fascinating.
It is. The cannabis plant produces phytocannabinoids, plant-based cannabinoids that happen to perfectly mimic the shape and function of our internal endocannabinoids.
Nature's weird like that.
It is. The two most prominent are THC and CBD. And because we have this massive network of CB1 and CB2 receptors throughout our gut and immune system, these external compounds can interact directly with our physiological machinery.
Let's look at how they interact specifically with gut pathology. Take CBD, for example, which is non-intoxicating. It doesn't get you high.
Right. CBD has a complex pharmacology, but one of its primary actions is its interaction with the CB2 receptors, which, as we noted, are located primarily on immune cells.
Okay.
When the gut barrier breaks down and the immune system launches a massive inflammatory attack, CBD can modulate those CB2 receptors to suppress the release of inflammatory cytokines.
So it calms the immune panic.
It actively turns down the immune system's panic response. This is why gastroenterologists are intensely studying CBD for inflammatory bowel diseases like Crohn's and ulcerative colitis.
Furthermore, recent microbiome sequencing shows that CBD administration can actually alter the demographics of the gut bacteria, promoting the growth of beneficial anti-inflammatory species. But what about THC? THC is the psychoactive component, and it binds very strongly to the CB1 receptors.
Because CB1 receptors in the gut are heavily involved in controlling the smooth muscle contractions, activating them with THC strongly inhibits peristalsis. It slows the gut rate down.
Which isn't always good.
Right. If you have a sluggish gut, that's not helpful. But if you are suffering from conditions characterized by rapid transit, cramping, and severe diarrhea, the targeted use of THC can act as a profound biological break, providing immense physical relief.
And the pain relief aspect of the ECS extends far beyond just stomach cramps.
Oh.
We have to discuss the opioid-sparing effects, which is arguably one of the most critical areas of medical research right now, given the catastrophic global opioid epidemic.
Oh, this is vital data.
I want to dive into the massive 2022 systematic review and meta-analysis published in Neuropsychopharmacology by Nielsen and her colleagues.
This was a landmark review. The researchers didn't just look at one small trial. They analyzed 92 separate studies to determine if the administration of cannabinoids could reduce the required dosage of highly addictive opioid painkillers.
And the preclinical data, the deeply controlled laboratory trials, is absolutely staggering. They ran a meta-analysis of 7 specific preclinical studies looking at the co-administration of THC and morphine.
The results showed a profound synergistic effect. The cannabinoid receptors and the opioid receptors share overlapping neuroanatomical distribution in the pain pathways of the brain and spinal cord. And they use similar intracellular signaling mechanisms.
So they team up.
Exactly. When they work together, they amplify each other. The review found that when THC was co-administered, the median effective dose, known as the ED50 of the morphine, was 3.5 times lower than when morphine was given alone.
Wait, they achieved the same level of profound pain relief using nearly 4 times less of the highly addictive, dangerous opioid.
Yes, 3.5 times lower.
And crucially, the review explicitly noted that across 6 preclinical studies, there was absolutely no evidence that adding the cannabinoid increased the abuse liability or the rewarding effects of the opioids.
It points to a massive potential for harm reduction. However, we do have to look at the full picture here.
Always.
The review noted that while the preclinical animal models were definitive, the clinical trials on actual human patients were much more mixed.
Right. The observational studies, where they just survey patients in the real world, showed massive numbers of people voluntarily dropping or reducing their opioid prescriptions when they gained access to medical cannabis.
True.
But when the researchers looked at the gold standard randomized controlled trials for acute and cancer-related pain, the opioid-sparing effects weren't nearly as clear or definitive. It highlights just how complex human pain psychology is compared to an animal model, and why we need vastly more rigorous human research.
And this brings up a crucial clinical caveat regarding how we actually utilize these external compounds. Dr. Kimber Rochford, a physician specializing in addiction and pain management, writes extensively about the clinical reality of the ECS.
What does he say?
He points out that because the entire purpose of the ECS is homeostasis stability, how you administer the cannabinoids matters immensely.
Right, he specifically warns against the standard methods of consumption, like smoking or vaping.
Yes. When you inhale cannabis, the active compounds cross the blood-brain barrier almost instantly. The blood serum levels spike massively, and then they crash just as quickly.
A roller coaster.
A huge roller coaster. And this violent fluctuation in cannabinoid levels can actually dysregulate the system further, compromising memory, executive function, and long-term stability.
So what's the alternative?
For actual medical intervention, he strongly advocates for stable, long-acting oral dosing. This provides a steady baseline of support that allows the ECS to gently guide the body back to homeostasis without the spikes and crashes.
Which raises a really fundamental question I have to ask you.
Okay.
If I am suffering from severe gut inflammation driven by chronic stress, and I use a stable oral dose of medical cannabis to calm it down, am I actually repairing the communication breakdown between the gut and the brain? Or am I just masking the pain? Am I fixing the engine, or am I just putting a piece of black tape over the check engine light?
That is the essential debate at the heart of functional medicine right now. And the biological evidence suggests that it is doing more than just masking pain. It is actively creating the biological conditions necessary for healing.
How so?
By suppressing the inflammation, slowing the hyperactive motility, and allowing the tight junctions to physically rebuild, you are giving the microbiome a chance to stabilize. You are interrupting the inflammatory feedback loop.
So you're creating a window of biological safety.
Exactly. You are turning off the fire alarm so the crew can rebuild the house. However, and this is the critical caveat, if the psychological stressor is still present.
If the Ouroboros is still consuming itself.
Yes, if you are still living out a false identity and chronically suppressing your trauma, the second you remove the external cannabinoids, the entire system will eventually break down again. You cannot simply medicate your way out of a psychological trap that is actively tearing your biology apart.
Which is the perfect realization. Targeted medical interventions, whether they are cannabinoids, SSRIs, or antispasmodics, can buy you time. But they are not the ultimate cure.
No.
To truly repair this network, you don't necessarily need a prescription pad. You need to change the physical and psychological inputs you are feeding the system every single day. We need to talk about rebuilding the connection through lifestyle and nutritional psychiatry.
Absolutely. If we accept that the microbiome is an ecosystem, then the foundation of rebuilding it is agriculture. It is what you are planting and what fertilizer you are using. And the foremost expert on this is Dr. Emmerin Mayer, a pioneering gastroenterologist and neuroscientist.
He's brilliant.
When it comes to diet, he doesn't advocate for extreme restrictive fads. He points to the overwhelming clinical data supporting what he calls the Mediterranean lifestyle.
Notice the word choice there, lifestyle, not just a diet.
Precisely. The nutritional components are vital. It is heavily plant-based, massive amounts of diverse dietary fibers, rich in polyphenols from olive oil and colorful vegetables, and healthy omega-3 fats. But the lifestyle component is equally critical.
What does that entail?
It encompasses the social joy of eating. In the Mediterranean tradition, eating is a slow, communal, relaxed event.
Why does the social aspect matter to my bacteria? I mean, food is food, right?
Because of the autonomic nervous system. When you sit down with friends, relax, and enjoy your food, you activate the parasympathetic nervous system, the rest and digest mode.
Ah.
This sends a safety signal down the vagus nerve. Salivary enzymes increase, stomach acid is optimized, and gut motility operates smoothly.
So if I buy a $20 organic, polyphenol-rich superfood salad, but I eat it while hunched over my keyboard, furiously answering stressful emails and hyperventilating about a deadline.
You are completely sabotaging the nutrition. Your body is locked in sympathetic fight or flight. Motility is suppressed, the blood is shunted away from your gut, and your system physically cannot break down or absorb those high-quality nutrients effectively. You have to change the context of how you eat, not just what you eat.
From a pure hardware perspective, what specific nutrients are we aiming for to rebuild the microscopic population?
You must focus on prebiotics and probiotics.
Break those down.
Probiotics are the live, beneficial microorganisms themselves, found in fermented foods like kefir, kimchi, sauerkraut, and high-quality yogurt.
And prebiotics.
Prebiotics are the fuel for those organisms. These are the complex, non-digestible carbohydrates and fibers found in garlic, onions, asparagus, and whole grains. Human enzymes can't digest them, but they pass intact to the large intestine where the microbes ferment them into those critical short-chain fatty acids like butyrate.
Which reduce inflammation and fuel the serotonin factory.
Exactly. And of course, the indoles from cruciferous vegetables to keep the amygdala calm.
We should also touch on how radical dietary shifts can be used for severe neurological intervention. Dr. Mayer mentioned the ketogenic diet. Now, pop culture views keto purely as a fast way to drop water weight.
Yeah, the fad version.
But neurologists use it very differently.
They do. The clinical ketogenic diet is a highly specific, high-fat, ultra-low carbohydrate protocol that forces the body to stop burning glucose and start burning ketones for fuel. In clinical settings, it has been used for decades to treat refractory epilepsy in children's seizures that do not respond to any medication. And it is increasingly being studied for neurodegenerative conditions like Alzheimer's.
How does eating massive amounts of fat stop a seizure in the brain?
Through the microbiome. Research indicates that the extreme metabolic shift of the ketogenic diet radically alters the bacterial populations in the gut in a way that massively upregulates the production of GABA.
The brake pedal.
Exactly. Remember, GABA is the heavy brake on the nervous system. By forcing the microbiome to flood the vagus nerve with GABA-promoting signals, the diet effectively acts like a natural, continuous dose of Valium for the brain, calming the hyperexcitability that triggers seizures.
It's incredible that a dietary shift can outperform synthetic anticonvulsants in certain cases.
It really is.
But for everyday gut issues, the chronic bloating, the irritable bowel syndrome, the random cramping, Dr. Mayer highlighted a therapeutic approach that completely flips the script. He noted that for functional gastrointestinal disorders like IDS, targeting the gut with pills is often less effective than targeting the brain with therapy.
This is the ultimate proof of the top-down effect of the gut-brain axis. Clinical trials show that psychological therapies, specifically cognitive behavioral therapy or CBT, mindfulness-based stress reduction, and gut-directed hypnotherapy can produce dramatic physical improvements in IBS symptoms.
Gut-directed hypnotherapy. That sounds like a magic trick.
It sounds esoteric, sure, but it is highly evidence-based. These therapies work by consciously retraining the brain's threat detection system. They teach the left hemisphere to start panicking.
I see.
When you use CBT to reframe your anxieties or mindfulness to ground yourself in the present moment, you literally stop the brain from firing that chronic stress signal down the vagus nerve.
You turn off the alarm.
Exactly. When the emergency broadcast system is finally turned off, the sympathetic nervous system powers down, the gut relaxes, motility normalizes, and the localized inflammation subsides.
It is the literal manifestation of meditating a better microbiome. And this ties perfectly back to the exact data we saw in the Nurses' Health study.
It really does.
The women who practiced cognitive reappraisal, who used psychological tools to reframe their stress rather than burying it, had physically healthier, more diverse bacterial colonies. By changing your perspective, you are changing the biochemical environment of your colon.
And to implement this on a daily, practical level, Dr. Rochford suggests adopting a tool widely used in addiction recovery, which is the HLT method. It is an acronym designed to intercept the Ouroboros before it spirals out of control.
Hungry, angry, lonely, tired.
Exactly. When you feel a sudden spike in generalized anxiety, a sudden craving, or an overwhelming wave of negative emotion, your left hemisphere will try to invent a catastrophic reason for it. It will tell you that your career is a failure or your relationship is doomed.
Right, it catastrophizes.
But before you let the panic cascade down the vagus nerve, you pause and ask, am I simply hungry? Am I holding on to localized angry? Am I physically lonely and lacking a social parasympathetic connection? Am I just chronically tired?
Just checking the basic gauges.
Yes. By identifying the root physiological or emotional trigger, you prevent the systemic fight or flight response. You stop the damage before it reaches the gut.
But what if the damage is already absolute? Let's say a listener had a severe systemic infection and had to take massive, broad-spectrum intravenous antibiotics. They essentially dropped a nuclear bomb on the microbiome, wiping out billions of years of evolutionary OGs. The anxiety is crippling, the digestion is ruined. How do you rebuild a raised forest?
For severe clinical dysbiosis, most notably life-threatening infections of Clostridioides difficile, or C. diff, where opportunistic, deadly bacteria have taken over the empty real estate, modern medicine employs the most radical microbiome reset available.
Which is?
Fecal microbiota transplantation, or FMT.
A stool transplant. Taking the feces from a healthy person and putting it into the colon of a sick person.
I know.
It sounds completely science fiction and undeniably a bit gross to the uninitiated. But the clinical efficacy is astounding.
It is currently one of the most remarkably effective therapies in modern medicine for recurrent C. diff, with success rates often exceeding 90%, far outperforming powerful antibiotics.
How does it work practically?
The process involves rigorously screening a healthy donor to ensure perfect metabolic and infectious health, processing the stool to extract the rich, diverse microbial community, and then delivering it directly into the patient's colon, usually via colonoscopy.
You are airdropping an entire mature ecosystem into a devastated landscape. But the most fascinating part of SMT isn't just the immediate cure, it's what happens months later.
Yes. Initially, immediately after the transplant, if you sequence the patient's microbiome, it looks almost identical to the healthy donors.
Okay.
The transplanted microbes set up camp, alter the pH, produce short-chain fatty acids, and drive out the deadly C. diff. They stabilize the environment. But as time goes on, over weeks and months, the donor's specific microbial signature begins to fade.
And what replaces it?
The patient's own original healthy microbiome profile begins to reemerge and repopulate.
Wow. Because the architectural blueprint for your specific, unique microbiome is stored deep within the mucosal folds of your own intestinal lining.
Exactly.
The donor microbes act like a construction crew. They come in, put out the fire, rebuild the scaffolding, make the environment safe, and then allow your own native species to come out of hiding and reclaim their territory. It's a profound testament to the resilience of the human body if we just give it the right biological support.
That is the ultimate takeaway here. The gut is not a dumb mechanical tube, and the microbes are not just silent passengers. They form a highly intelligent, intensely sensitive biological mirror that reflects your emotional life, your diet, and your environment.
I want you, the listener, to reflect on your own daily reality for a moment. Are you constantly trying to fix a gut issue, the bloating, the acid reflux, the sudden cramps, by popping an over-the-counter pill, when what you actually need to fix is a chronic, unspoken stressor in your life?
A very important question.
Are you ignoring the Ouroboros? That knot in your stomach might not be a food intolerance. It might literally be your enteric nervous system screaming at you to quit the toxic job, to have the difficult conversation you've been avoiding, or to finally seek therapy to process an old trauma. You cannot heal the tissue if you don't address the signal.
You cannot separate the mind from the matter. They are the exact same system.
Let's summarize the truly incredible territory we have covered today. We started 3.5 billion years ago, looking at the ancient microbial architects of life that eventually colonized our bodies, building a massive communication network via the vagus nerve, where 90% of the traffic flows upward to inform the brain.
A huge journey.
We explored how the psychological trap of our modern, divided mind, the manager, crushing the explorer, triggers a relentless fight-or-flight response that halts our digestion and literally tears our intestinal tight junctions apart.
And we saw the chemical fallout of that?
Right. We saw, through the nurse's health study, how suppressing our emotions visibly starves our beneficial bacteria and shuts down cellular energy production. We looked at the germ-free mice to understand how bacterial byproducts like indoles physically turn off the panic valves in our amygdala.
The neurotransmitter factories.
Yeah, we navigated the vast chemical factories of serotonin and GABA and the master regulatory power of the endocannabinoid system. And finally, we explored how to consciously rebuild this entire network through the Mediterranean lifestyle, cognitive behavioral therapy, the HLT method, and the radical promise of microbiome transplants.
It represents a paradigm shift that changes the trajectory of modern medicine. But as we close, I want to leave you with a broader, perhaps slightly provocative thought to mull over.
I'd love to hear it.
When we look around society today, we are witnessing a massive, unprecedented global epidemic of anxiety, depression, and cognitive decline. And we typically frame this crisis entirely through the lens of human psychology and sociology.
Right. We blame the economy, we blame the isolation of social media, we blame the modern news cycle. We think it's a software problem.
But what if the root of the crisis is far deeper and much older than social media? What if this mental health crisis isn't just a psychological failure, but the visible symptom of a mass extinction event occurring invisibly inside our own bodies?
A mass extinction event.
Yes. Over the last century, we have systematically hyper-sanitized our environments. We have bathed our food supply in pesticides and antibiotics. We consume diets consisting heavily of ultra-processed, completely sterile, fiberless foods. And we trap ourselves in chronic, unrelenting corporate stress that degrades our intestinal walls.
We are waging war on the exact organisms we need to survive.
Precisely. We are actively starving, poisoning, and killing the very microscopic allies that evolved alongside us for billions of years to keep our neurological hardware stable. We are stripping away the chemical shock absorbers of the brain. So the question is, are we losing our minds because the modern world is too stressful? Or are we simply exterminating the ancient microbes that taught our brains how to feel safe in the first place?
Wow. Are we exterminating the microbes that taught us how to feel safe? If that doesn't make you look at your next meal and your next stressful email differently, nothing will. It brings us right back to the realization that your body is not a machine. You can't just take it to the mechanic, replace a broken part, and expect the engine to run perfectly if the soil the engine sits on is poison.
Absolutely.
You are a vast, complex, interconnected ecosystem.
Yeah.
And it is entirely up to you how you tend to that garden.
Well said.
Thank you so much for joining us on this deep dive. Take care of yourselves, take care of your microscopic partners, and please listen to your gut, literally.